Hello and welcome to yet another video. Today we have an Asrock B450 Gaming K4, as you can see right there. And if you say, hey, didn't you just repair one of these mainboards or this mainboard? And to that I can say, yes I did. This is the second one. By chance, we actually have the same board again. So, this time I have no idea what is wrong with this mainboard. To remind you, the last time we had an octave resistor in the CPU area right there at the top. And we thought it was the BIOS, but it wasn't the BIOS on the other one. And for this particular one, I have no idea what could be wrong with it. I see a lot of dust, like this board is filthy, if you can see it. I think this shows it very well around the VRM coolers. And I have no idea what is wrong with this board. Probably no boot. Or the only description I got is that it doesn't work. So, what we're going to do is we're going to build this board up together. And we're going to see how this one will behave. But first, before I do that, I might just use the air compressor to push out some of the dust out of the DDR slots, because I can already see dust in the DDR slots and it will not work with that. So let me quickly do that, and then we're going to build the board up and see what the power consumption does. And now our board is fully built up. Now look at the power consumption. I'm going to connect the lead, and we have the same power consumption that we had the last time on this Asrock board. Because of the flickering LEDs, it is non-static. It is going up and down because these LEDs here are pulsating, as you can see. And now let's hit the power button and see what happens. And I don't know if you can hear that, but there's a clicking going on in my power supply. And clicking in my power supply usually means that there's a short circuit on this board. So what we're going to do is we're going to remove the 8-pin connector for the CPU, and we're going to see if that happens again. And now it doesn't happen anymore. So now we have normal power consumption, but VCore is missing. So what we now need to do, we now need to take our multimeter. We now go into resistance mode. Let's put you somewhere where you can see that better. Hope that will be fine. And let's now go across the 12 volts. And the 12 volts has almost 0. So we have a short on our VRM somewhere. So next thing we need to do, let's disconnect everything from this board. And we need to take off the coolers of the VRM. And then we're going to see if we can already see something by visual inspection, or if we're going to need voltage injection. And holy smokes, what awaits us here. Look at these thermal pads. What in the actual happened here? I don't know if you can see that. Probably you can't because of the focus. Come on, camera, focus. There are parts of the MOSFET still on here. I have never seen anything like this. I was already, while I was trying to take this apart, I saw this at the back. And I was already, there has to be something massively damaged here. And as you can see, we need to take a closer look under the microscope for this one. Well now, this must be the worst explosion of a VRM I have ever seen. Like, this is massive. Look at how much damage this has caused. This must have been a legit fire. Look at these layers. The very interesting thing was, when I disconnected the 12 volts power, the power consumption looked very, very healthy for the board. So it was drawing about 2 amps and it looked very good. But this, I got to be honest, I have very little hope for this mainboard. Because the big thing is, there are just layers fused together probably here and shorted into very, very deep layers. I will be trying to remove these MOSFETs, but I have very little hope. What I probably need to do, I need to remove these caps here first, and then I will need to see if I can get to these MOSFETs. But there's so many passive components that are also damaged and just destroyed here, as you can see. Just so many resistors that just blew up. I cannot even tell you how something like this, this cannot be just a normal 12 volt short. I cannot imagine this happening from just a regular short. But we're going to see what we can do. So I'm going to try to remove those big electrolytic or solid aluminum caps first, and then we will see if I can desolder any of these leftover MOSFETs. So this will take quite some time for me. I'm going to probably film some of it, but I'm not sure if I'm going to show you it or if we are going to see each other again as soon as I'm finished with this. So I've cleared a little bit of the charring away, and I just wanted to show you a little bit how it looked like. So we can now see a lot more of what happened, and it's pretty much exactly where the VRM ends, that it is here with the burning. And I now have the task to remove these MOSFETs and see if they have fused to the layers or not, and if the layers underneath are shorted to ground or not. And I will also have to look at like components like this, because this looks burned as well, and then all of the passive components that are in between here as well. And I'm just going to flood the area with Flux now, and going to use my hot air station and going to see if I can remove any of that. And so I have to come to a point where I got pretty deep into the board, as you can see down there. And what is actually there is the other side of the board that you can see. There's a hole actually in there. And that was what we've seen on the other side. And I'm still trying to pick away on this, but I'm not too sure where to continue. So what I will do next is I will attach ground to there and attach 12 volts to here. And I will send, well, not 12 volts into there, but like start with 1 volt and see how much amps it takes. And then I will see what gets hot and see if I need to remove any more layers. Some layers may burn through even more, and I will have to continue to remove them. As you can see, there are quite some cut marks that I have here and quite some here, and we will see how much more of the fiberglass I have to remove before the short is gone, and I will see you then. So, and right now I've hooked up my power supply to one ground point and to this point, and so this side is one of the coils, this side is 12 volts, so we now have no direct short anymore into the phase. And what I'm now want to do is I want to see if we still have a short to ground. So I'm going to switch this wire to ground, and then we're going to see if we still have a short circuit. And let's see, we're now going to connect this clamp onto ground, and as you can see, we have an amperage draw of 20 milliamps at 2 volts. This doesn't seem like a short anymore. Let's increase the voltage up to 12 volts. And as you can see, the amperage is going up. And we're shorted, as you can see, because we were drawing 10 amps. And there was something else that blew up. We have, you can see it, and you can't smell it especially. We have more MOSFETs that have blown, and we have a capacitor that is also blown. So there's more damage in the VRM, and now we have to take out at least that capacitor, and we need to see again if we see what of these MOSFETs failed and also remove them. So first I'm going to remove that capacitor that has blown up right here, and then I'm going to continue my search. And right now I had to remove more of the VRM because more of capacitors blew up, because there was still some MOSFET shorted. I removed the whole side of the MOSFETs here, and what we can see, this MOSFET is shorted to its gate, and on this MOSFET right here, it is shorted to gate and to its drain and source. So these two are dead. The others tested okay. And now I'm still going over to see if my resistance goes any higher than before. If I can actually supply 12 volts at some point to this. Because if we probe the V-core side, which you can't see right now, let's switch you over to the microscope. Oh, the microscope is already switched on. If we probe this side here, so the input of the inductor, and we use ground, we right now get a reading of 3.75 kilo ohms. This is still too little. This should be like 10 kilo ohms and rising. But now I have the problem that I don't really know where the problem could lie in, because this resistance is too low for me to inject any voltage. And if I go from 12 volts onto here, I have also kilo ohms, but that looks good. I have above 10 kilo ohms, but from ground I only have, as I said before, 3.7 kilo ohms, 3.75, and that is still a problem. So I need to find out why we still have such a low resistance to ground on here, and I'm going to see a little bit around the area, and if not, I'm going to start to connect 12 volts again to the actual power through my power supply, and I'm going to see if anything else blows up. And now I've currently hooked up 12 volts to its supply, and I get no amp draw anymore at all. And just to be sure, as you can see on the power supply, that was me touching with the 12 volt lead to ground, and we have nothing happening. So we have no shorts anymore on the 12 volt side. I'm not really sure how to proceed with this right now. I'm going to clean up the area a little bit more, see if there's nothing shorted anymore, and then I'm actually going to try to plug in the 12 volts from the power supply and see if vCore still is being created on the other phases. And so now, I've spent over an hour now trying to clean up. I've removed all of the side of the VRM. I removed quite some components there. I had to do quite some work on the back side because we actually got all the way through to the last layer. So there's a lot of wires broken here. I haven't gone into any diagnosis anymore. The only things that I've now checked is that 12 volts is not shorted to ground anymore, and 12 volts is not shorted anymore to the vCore. So I don't have very much hope for this mainboard anymore because there's just too much damage, to be perfectly honest. And the VRM controller also is probably damaged. But what we are going to do now, as one last thing, is we're going to connect this to 12 volts power to my power supply. And we're going to put a CPU in there because this board probably needs a CPU to even start up. And we're going to see how the power reacts and if anything changes. I've removed all of the phases on the left side. There's still some left at the top side. I think they're all good. They were separately from what has happened here. And I might even be able to build up some of these here. And that will be, if this doesn't work now, which it probably won't, I will actually try to build up phases here. And I'm going to see if that changes then anything. But for now, let's plug in a processor into here. Let's get my 2200G. Hope that it doesn't get straight up 12 volts from anywhere. And let's see now. I'm going to turn this on. This now has... We don't see any power consumption yet because I haven't connected my leads, and now the leads are getting connected and the positive, and we have the milliamps that we should have. And now I'm going to turn this on and we're going to see what happens. And 1, 2, 3. We turn the board on, and as we can see right now, there's almost nothing happening actually. We have an amp of current draw. We have nothing getting hot, nothing blowing up, the power supply not going into protection mode. So we have cleared the short on 12 volts definitely, but now it's probably looking for vCore and can't find that anymore. So what I'm going to do, I still have the good MOSFETs that were on here, and I'm going to build at least 2 phases up, and we're going to see if we have any change then. So I'm going to quickly do that, and then I will see you again. And right now we have a single phase restored, as you can see right there, and we're going to now try yet again, and let's see if we have any change. But we have no change in amperage draw. We have nothing on vCore probably. Yep, we have nothing on vCore. No voltage. And I'm going to try to build up more of the phases. And we're going to see if we have any difference after that. So, I now want to wrap up this video, because there's one more thing that I've seen, which is the final nail in the coffin for me to proclaim that this board is dead. As you can see, the VRM controller heats up drastically, so this is shorted as well. This heats up to very high. This is almost at 100 degrees right now, at the hottest point probably already 100. And with that, there's just no hope for this mainboard. I mean, as soon as you saw this mainboard was hopelessly. But it was an interesting experience for me to carve this out, to actually see if anything could be saved. Actually building up the rest of the VRM back again that I could, and use some donor parts. And yeah, I've never taken off this kind of layer off of a PCB. At the end, I think we had about, I'm not really sure, I think like 5-6 shorted MOSFETs, something in that area, and it's just not economical. I'm actually positive that everything else on this mainboard actually works. So all of the other circuitry, like the Super I/O with the PCH, everything else works fine. The DDR, I just think it nuked the whole VRM area. So the interesting part would be if this could be E-powered. Like if you've seen on a graphics card, an E-power is something where you take the VRM of a different GPU, you cut it up, and then you just attach it to the GPU. And the big problem to another GPU to power it. The big problem is all the signaling stuff. So especially the stuff around the VRM controller to signal that CPU vCore is good, that the CPU is present. All of that signaling stuff has to be connected elsewhere on the board, like to the PCH and the Super I/O. So I don't think that is something that I will do, because it would be way too time consuming and would really not be worth it for this board. So this board is sadly going to end up as a donor board only, and there was nothing I could do for this board. I spent almost 2 hours now, and basically from the beginning on, I knew that those 2 hours were wasted, but I just wanted to try it out to see if I can get anything out of this. But sadly, this is an absolute no-go. This is absolutely dead. So I hope I still could give you some interesting shots. This were some of the most unbelievable blown up VRM that I've ever seen. So this was a picture for itself, but there's nothing else we can do for this. I hope you still enjoyed watching. Thank you very much, and goodbye.